Hello, my name is Dr. David Tamajan. I'm the Director of Marketing at InfoSim. I'm pleased to welcome you today to today's collaborative webinar looking at how we're actively engaged in pioneering autonomous self-healing living networks. Let me just quickly set the stage for the story that we want to share. It's the direct result of a catalyst we presented in June of 2026 in Copenhagen for TM Forum's Digital Transformation World event. TM Forum represents over 850 companies and is essentially a massive global nonprofit defining the rules and operating models for the entire communications industry. A huge part of their mission is driving the industry towards open architecture and standardized APIs, primarily through frameworks like the Open Digital Architecture, ODA. Their Catalyst program, of which this is a part, is a critical platform. It fosters and inspires industry innovation. Catalysts are basically fast-paced, collaborative projects where companies, even sometimes competitors, team up to solve massive real-world technical headaches, hopefully leading to a tangible functional product. Our collaboration is a result of a global effort involving a dream team, if you will, of 14 different organizations. You've got major champions, the service providers like Verizon, NTT, MTN, Orange, and Telin, driving the real-world requirements, and technology partners like InfoSim with our automated network and service management solution, StableNet, and Beyond Now, building the actual solutions. By leveraging cutting-edge tech like AI-driven automation, digital twins, and predictive analytics, we're moving past the theoretical and into live demonstrations within real service provider environments, proving that level 4 autonomous networks are ready for prime time and can sense, decide, and act on their own before a human ever needs to step in. The project is already hitting some massive milestones, an 80% boost in traffic resilience, 50% kind of manual operational time, getting services to market 60% faster. You'll see all of this in the coming slides. Ultimately, we want to highlight this fundamental shift from just reacting to network outages to preventing them entirely. And with that, I'm going to go ahead and hand it off to our first presenter, Delphi. I'm going to let each of you just present yourselves as you get started. And go ahead, Delphi, if you'd like, you can take it away.
Yeah, thank you, David, for such a nice introduction. Thank you, everyone. Thank you for taking the time to join this webinar. My name is Delphi. I'm currently serve as the manager, internet and connectivity based platform at Telin. So Telin is actually an international arm from Telkom Indonesia, the largest company here of the internet provider operator in Indonesia. And then my role is mostly managing on the digital service and also digital platform. So welcome everyone. So welcome to our project. So this is actually the Living Network Phase 3, which is being showcased in the Copenhagen this year. So let me start by confirming that we're actually facing something as the champions or as the operators that is actually being faced around the world. So right now, we are actually facing an issue that is everyone is using the gaming session, live payments, and also the emergency calls where we cannot have like a retry, we cannot have like a second chance. Those are the services that cannot be dropped, meaning that the moment they drop, meaning that there is something actually in the service wise that is going to be affected. And also the second one, we are also facing that we know that the fact, although we are actually talking on the level 4 autonomous network, but fact said that only 30, there are already 30% of us of the champions are actually still at the level 0 to level 1 autonomy. So this is actually something that we need to look at as well. And also the last one would be we think that we need like a zero tolerance sectors. We know that the sectors like hospitals, factories, and also financial system, we cannot have a margin for error in that kind of situation. So that's why we think that the downtime is not an option for that. And also, we got a testimony from one of our customers. They're saying that they are actually losing 40% of active users in the moment when the session drops. So And also the one thing that is very interesting over here is that they actually used to discover the outage from the angry users or from the complaints is not from your NOC. Their NOC is only acting when they're actually seeing the complaints comes in, and then that is actually the thing that we are facing today as one of the champions. And also, I believe that most of the champions are actually still facing today. That's why I think why the solution is actually very needed in this time, and also why we think that those kind of the problems becoming the foundation of this solution as well. So, what are the core problems in this project? We think that the mean time to repair is high, the OpEx is also high, and also that is the thing that is becoming the challenges that we want to tackle using this solution. So the first one is that we think that the approach is still very reactive, where uh, we actually want to have it more into the proactive approach. And also the automation is there, but it's very limited. We can see the alarms, but we don't do anything with that. So that's why we want to achieve into the full automation, where it's not only about seeing the network alarms, but really into the execution of the network itself, translating the business intent into the production networks. And also the complex chaos is also becoming a real problem over here, where everyone, I think, having the multiple systems, manual steps, and also it creates a lot of confusion. So that's why we want, by doing this catalyst, we want to create a simplify how to automate these challenges, these complex chaos into a simpler and also flexible and easier to manage, of course. And the last one, this is also very important for us is that we want to have a solution that is also supporting into the energy saving. So we want to, of course, we want to have like a full autonomy. We want to have like a full automation, and we want our networks to be always ready and available. But at the same time, we actually want to do the power saving of the opportunities where we create a solution in which the AI identifies the power saving windows and acts automatically. So in short, what is living networks? So living networks is that a solution on the networks that can predict, fix themselves, and run very smoothly. So the next slide will be explained and managed by one and only Andreas. There you go.
Thank you, Delphi. So in this Catalyst project, I did participate with two roles from two different organizations available to me. One is representing my company Beyond Now and using our digital business platform for parts of the functionality, but also participating as co-chair of TM Forum's Open API program, where we are always seeking a lot of input from the Catalyst projects to test and try and improve the APIs that are an important part of TM Forum's industry standards. Speaking of organizations, it's not only TM Forum that was contributing standards to this effort. We've also been incorporating standards from 3GPP, Metro Ethernet Forum that's now branded as Amplify, and the Camara APIs from Linux Foundation. And this did also not start this year. This is already phase 3. And while in 2024, we did our first definitions of a reference architecture for these challenges. And in phase 2 last year, started with the closed loop automation across the many domains involved here. This year, we focused on intent-driven management to solve and help with the problems in front of us. There's a lot that was called to action here, also using digital twins and predictive analysis, creating real-time dashboards to show the output of our effort on management information level. And so this was a rather large project compared to previous efforts. If we switch to the next slide, I can show you our reference architecture, where you also see the elements from many of the participants, InfoSim, allowing us to use StableNet as one of the core elements for the assurance layer here, and Globidom's contribution for the service orchestration and API gateways. Lots of contributions from Orange that will be shown in detail later, and NTT and NICT from Japan as a pure research organization as well, contributing their LLMs and stuff. The one thing where our catalyst is special in the whole range of many autonomous networks focused catalysts is that we are not only looking at the automation, we are also looking at the business control of it. Because the input that we have from our sponsors and champions is that all the AI-based automation does not only need to run smoothly, but it needs to be controlled by the business level. And so we specifically took care of making sure the APIs for this feedback loop into the business domain, checking the cost element of any change that the autonomous level is trying to do to improve, does have a business case behind it and is allowed on a business level. And one of the things that we added and built in this catalyst was to make sure we can use the performance management API from TM Forum, enhancing it with a capability to include intent management and actually transport the intent report, which was previously not possible with the existing standards. And this is our contribution back to the TM Forum standards, that this was developed in the catalyst and will subsequently become part of the standard. With that, over to David. David, you're on mute.
No, I'm not. Thank you, Andreas. We have also much more material on what we contributed. For the sake of time in this video here, we will not show all of this in detail, but that's maybe also the right moment for me to just say, please visit also our page of the Catalyst on the website. And with this, I'm also switching to my browser here, actually. I want to show now a little bit the live demo part of our presentation. And as I said, please make sure you also have a look at the website of the Catalyst, because there's plenty of additional material on what we are doing. So to the live demo, really quick, won't spend long time on this part here, but as we also have our StableNet audience in the call. We have, as Andreas has pointed out already, we have been in the integration part on the resource managing layer. So we have, of course, had discoveries for getting the data in from different partners. We have weather maps showing different things. We have then obviously the devices themselves with the topology and so on in the network. And we also have the actual data coming from the devices. And now the challenge that we had to face is with 14 partners being part of that Catalyst, with many, many use cases being covered. we needed a nice, let's say, state-of-the-art way, 2026 at a show, to both show this to C-level people, but also to technical people, to make sure that it's well understood what we are actually doing, how to show this technical complexity. And to that end, following like the newest possibilities that are available right now, we decided that we actually prepare an interactive web site where you can dive into the different use cases and dynamically get more information interactively. And what I will be showing now in the next few minutes is basically just a quick look around on what we have also been presenting based on this in Copenhagen. And let me first start here with this overview page. So we had identified 4 main use cases that we have elaborated on a little bit more in Copenhagen, which are again the subsea cables and predictive maintenance, which has basically been with us since the first phase of the Catalyst. I just quickly click here and dive into this. So here you can basically see all of the data you see here is coming live out of StableNet. So it's just a different way of representing it once obtained from StableNet. So you see here a geographical map with the data. We have then also the individual endpoints. Of course, a lot of the data needed to be anonymized because not everything can be shown, but you can at least get some kind of understanding. And we then also have the actual measurement data, which is live being loaded from the system while I speak here. So should be available in a moment. There it is. Just let me pick some other measurement where we have something more interesting, but I will have more use cases in a moment. And we also then have we also then have in the okay, so the data is loading here. There we are. And we also have, for each of the use cases, we have something that is called a gallery, where we basically had the possibility to have additional video and picture material from different partners so that we can just show more things quickly without having to switch around between a lot of different laptops. So for instance, in this case, you have a short video from the website of Tallinn where they are showing more information about their subsea cables, and you can get an impression of one example here of a subsea cable EIG, the Europe-India Gateway, just as an example here. So let me quickly show another use case here. We were also very happy that we got actual live data from a mobile part of the mobile network in Tokyo. If I zoom in here to Tokyo, we actually see that we have one district of Tokyo where we have mobile station data. Again, understandably, this is not fully openly shown all of it. It's basically just anonymized to some cryptic numbers, which stand for the base stations. And we have also slightly had to move the base stations around. So you will not find them at this very place where they are shown, but it gives you an indication that in this case, we have 69 base stations in that area. And again, we have measurements. And in this case, what you can see here, when we are looking at some example measurements, I'm just showing a few of them. This is one of the examples. Let me pick another one. What you basically see is that the pattern that you see is not always the same, but it changes. And this is actually because the pattern you see is an indication about when base stations are switched on and off in order to save energy in an intelligent way, following the movement of users in the mobile cell. And this can also nicely be shown again with a video that has been contributed, in this case by 2 partners from NICT in Japan and from Changhua Telecom in Taiwan, where they are basically in a short video they are just explaining that they are, for instance, predicting the movement of these users. So you will see that the cell is actually switched off when the users move away. Behind that is an algorithm they have been proposing and implementing. The video is also then showing here that this has been linked to Team Forum APIs and ODA. So it's also possible to interact with this on a Team Forum level. And last but not least, there's also a calculation being done so that there are being financial numbers put to this. So people also get an impression on what is actually the cost saving by being intelligent in handling my mobile network. And again, This is another use case we have been looking at. I want to show one third use case before then handing over to my dear colleague Maria to show the last use case. So the third use case I want to show from my side here is the remote maintenance and smart factory use case. In this case, we are now focusing on a scenario that we have also already been looking at in the second phase of the Catalyst. And we have actually at the show floor, unfortunately, this is hard to do right now in a webinar, but at the show floor, we have actually been presenting this with a 3D model that we had prepared. So we had a map here of California and Nevada from West Coast in the US. And we had two factory locations, one near Las Vegas and one near Santa Monica. And this tiny hexagon here was the TM Forum, basically indicating that there's a lot of TM Forum ODA involved in making all this. And when I move to the next picture here in the gallery, you can see it a bit closer. So this was Delphi holding it. And basically what we are looking at right now is the following. Consider that you have in Las Vegas, you have a technical guy who needs to fix an issue remotely in Santa Monica. And for some reason, he doesn't have the possibility to travel there, but he needs to do it remotely. So he needs an improvement to his mobile connection, let's say a better latency, higher bandwidth. And that actually involves the full process that now the autonomous network is working in the background, actually realizing this demand and provisioning this to him, starting from a chatbot. And this takes me to the next issue that we actually have with the complexity of our Catalyst. So as you can imagine, with 14 partners, there are a lot of things that need to be integrated and a lot of players coming together and interworking. You had the slide before that Andreas has shown with the reference implementation and how all of this gets together. And so the next thing we wanted to show at the show floor is actually how this is technically working and have this again in an interactive way. So to that end, we have decided that we actually come up with yet another AI improved presentation where we are basically showing the interaction of the different components. So just really quick, on the lower right side, you see again the reference implementation, which is being depicted by, let's say, a lot of human effort, many people working together, putting their brains together, putting a lot of effort in designing this in a nice way. But in the same time, this is cumbersome to keep up to date, and it's even harder to completely animate it to show all the workflows between all the different components in a fully animated version of this. So that's why we decided we need something where we basically describe this complex picture here in some kind of machine-readable format. And we need to basically just one by one be able to show the different interactions, who is interaction. Like I can click here, next. And you actually see the interactions of the different components. Like the first step is the customer is talking to the chatbot. Let me maybe show this with a short video again in the previous presentation. So imagine that the customer now needs some extra bandwidth. So it's talking to a chatbot, which has been provided here in this case by Entity. And the chatbot is actually asking, okay, from when to when do you need it? Between which locations? So there's some interaction going on. That's the first step where the intent is coming in. And now if I'm switching back to my view here, I can step by step follow up what's actually happening. So the customer is talking to the chatbot. The chatbot is actually contacting the digital business platform using a TMF 622 plus intent. Translating this to a customer requirement, translating the customer requirement into a service intent. And then from there, we are moving further to the Globitom end-to-end service orchestrator. So all of this process that is normally happening in the background, because if everything is working autonomously, you don't see anything happen anymore. We are able here to show this, how this is technically working. So there's a service ordering then, TMF 641, plus intent being sent. From there, we move further to the RAN domain, which is from DGS. So now we are down here in our reference implementation. And from there, we move further to the, actually the RAN domain is recognizing an issue and is now sending back a problem report. Hey, something needs to be done. I can't actually realize that intent, so I can't actually offer that based on the current configuration. We need to reconfigure something. Something needs to be done here. And this is where the service assurance comes into play from InfoSim. And this is being handed back to the end-to-end service orchestrator. And now the end-to-end service orchestrator using MCP is actually talking to the digital twin offered by Orange. And there we are actually now looking into more details of the of this topic, and based on the work that has been done by Orange, are there now looking into solving the issue. Frederick, do you want to present the Orange part now? I have the video ready, or should we do it as a drill down later on? Up to you.
Yes, David, we can do it now.
Okay, perfect. Then here we are. I'm going back to my view here, and I have a deep dive video from Orange. So I'm switching off the sound here at my end because Frederick will talk to it. And Frederick, I'll switch on the video and you talk. Thank you.
So maybe you can put the sound also because it's Ikram speaking. Yeah.
1 second. Perfect. Then I'll just, that's live. Here we are. Oh.
Hello, my name is Ikram, and today I'm going to present my contribution to the TM Forum Catalyst project. In this work, I focused on the modeling and resilience evaluation of the 5G service chain using a digital twin approach. For the resilience model, I considered two main service chains, the user plane chain and the control plane chain. These two chains are considered in series at the global service level, which means that the overall service availability depends on the availability of both parts. Before implementing the digital twin on the Thinking digital twin platform developed by Orange, I first developed an ontology to describe the different elements of the 5G topology that I named generic 5G network ontology. This ontology defines the VNFs, the microservices, the pods, and the servers. It also defines the relationships between them. For example, each VNF has microservices. Each microservice may have a replica or many replicas. Each replica is deployed in pods, and finally, each pod is hosted on servers. I have also defined several attributes or the data properties for each element. At the VNF level, I included attributes related to the 5G servers. At the infrastructure level for pods and servers, I used attributes such as MTTF, repair time, creation time, termination time, CPU capacity, and memory capacity for the servers. And these attributes are then used as input parameters for the resilience evaluation model. Now, let's move to Thinking to see how this digital twin is represented. Okay, so here we can see the different VNFs that are created in the service chain. The topology includes CU, DU, UPF, AMF, IUSF, UDM, SMF, and PCF, and each of these VNFs are represented as avatars in Thinking. If we zoom in each VNF, we can see that, for example, here CU is composed of 3 microservices per default, and each microservice has 2 replicas, and each replica is deployed in a pod, and each pod is hosted on a server. If we click right on any component, we can see the different attributes of this component, of this, in this case, the pod. And these attributes are totally editable on Thinking via this button that we can update easily. After creating the topology in Thinking, I developed an extraction model. The goal of this extraction model is to retrieve the topology directly from the platform, including the VNFs, microservices, replicas, pods, servers, their attributes, and their relationships. Now, I will show the extraction part. So the model connects to Thingy through the API and collects the digital twin data. Once the data is extracted, it is classified by type: VNFs, microservices, replicas, pods, servers, and the relationship between them. Then this extracted topology is used as input for the resilience evaluation model. So first, we calculate the availability of the replicas, then the availability of the VNFs. After that, the model calculates the availability of the user plane chain and the control plane chain that will be considered in series. So the total availability of the 5G service chain is obtained by multiplying the availability of the user plane chain by the availability of the control plane chain. So in summary, my contribution includes the development of 5G ontology, the creation of the digital twin in Thingy, the modeling of the user plane and control plane chains, the extraction of the topology and attributes from Thingy, and then the implementation of a resiliency evaluation model focused on availability. And this workflow allows us to move from a static description of the network to a digital twin that can be used to analyze and evaluate the resilience of a 5G service chain. Thank you for your attention.
Yeah, so Frederick, maybe you can add a few sentences, and then we can later on, if people have further questions, they can reach out to us. Exactly.
So yeah, just wanted to highlight that this work on the digital twin and modelization of the network to compute the resiliency was used in the catalyst also to evaluate so some intent management. So typically to test different intents based on the digital twin platform and to see what is the effect on resiliency. So this was how ICRAM's work has been used. So all this work is also based on a research project which is managed by Guillaume and ICRAM. It's called MAR 6G, which is a European project. And of course, for Orange, it is a strategic topic. We are very much involved in this area of resiliency and of network digital twin. We have already some deployments ongoing in our affiliates. And so this is the topic also we are promoting in standard organizations. So of course TM Forum, but also 3GPP, for example.
Thank you, Frederick. And maybe with this, I'm also adding from my end a similar angle. So we are also happy from InfoSim side that we are actually having other research partners in the project. So the University of Würzburg has been heavily working together with us in the sustainability space, which also went into the catalyst for energy efficiency topics. And this is also as part of a German-funded research project, StableNet, which is again in a Celtic Next framework. And we are also happy that we have NICT. I already mentioned them as a Japanese research institute. So I think this is also maybe a specialty of our catalyst that is worth mentioning, that we had a strong presence also of research institutes and of that research work in the background. And now finishing quickly this scenario. So as you can see, if I go step by step, so the digital twin is actually helping to simulate different possibilities and to then solve the issue. And if this is done, finally, the service orchestrator is being informed that now there is a solution proposal. It's again going to the RAN domain with a TMF 921 intent management call. And based on this, finally, it's possible to do it. So the RAN domain is reporting back with TMF 921 that it has actually been done. reporting it back to the digital business platform based on TMF 628. And finally, it's going back to the chatbot, and the chatbot can tell the customer that now it's being done. So this would be like the second video here, which I'm skipping for the sake of time. But at the end of the day, you have a full visualization end-to-end of the interaction of the different components, which again also helps technical people to get a better understanding how this autonomous networks actually can look like in practice. And with this, I want to move to the last of the 4 use cases that we have in our scenario list here, and want to hand over to Maria from MTN, maybe to talk a little bit about what we did together here on the microwave backhaul in Africa. Thank you.
Okay, thank you very much, David. And once again, I'm happy to collaborate in this project. And briefly to let you know, I'm from MTN Nigeria, and we have the biggest techno company in Nigeria, right? And our transport on the access is predominantly microwave, right? And we are faced with this problem of operational maintenance and capacity planning, and most importantly, customer service experience. Customer experience is key for us. So in this project, what we have done is to first, David, could you move to the, okay? Is to use machine learning.
Yeah,
to use machine learning to. What we've done first is to use machine learning to cluster the links, because we have thousands, more than 50,000 links on the network. So we cluster the links to be able to get a behavioral pattern, and to be able to help us with this behavioral pattern, we can predict usage and at the same time predict any problems on the link. So in this clustering, we're able to identify patterns that will help us first to diagnose issues, and second to predict future problems, and third to be able to plan capex on the capacity of the links. So so basically what you see here is the different links. These are thousands of links clustered to different clusters showing different patterns and different growth. And what happens is with this, we can easily understand the different links, and then dig deep and pick the individual links and see what we can do when it comes to expansion or even rerouting links to be able to meet our customers' needs. David, please, next one. The next. So this one's see the same thing showing here. So basically, when we come to this particular one, now we have clustered the links. We are able to identify the behaviors, and we are able to see fault patterns, or we are able to pick up capacity issues. So in this particular pipeline, this is to diagnose the faults. So the faults on the links. So here it's basically to pick up the faults using different deterministic machine learning algorithms to able to classify the links, able to prioritize links based on severe, critical, preventive maintenance, and these different power outages. These different categories proactively help us monitor, proactively help us to fix any structural issues on our links, and thereby making sure that our customers don't even feel any problem at all. So as these links are clusterized and categorized, automatically it goes back to the human aspect of it that go to the field to fix the problems. So summarily, this particular project has given us a very beautiful foundation to be able to proactively predict the customers' issues when it comes to the transport, and proactively fix them of course, it still feeds back into the bigger picture of intent-based management and resilience. But most importantly, in this particular part of the network, we're able to proactively diagnose faults, categorize, prioritize, and fix these faults. David, that is
so I'll switch to the slide, right? To the outcomes.
Yeah. So in summary, to conclude, what we have on the outcome for this catalyst is been like you already observed, it's been a beautiful journey with different partners. In fact, with the research institutes, and most importantly, is the use cases we have as a customer that is driving us ahead. So if you look at our catalyst outcome, if you look at the customer, I always start with the customer. For this particular project, the SLA. What's most important is our SLA compliance, right? The NPS. Based on this, if you bring everything together minus our MTN our MTN contribution, you realize that the idea of this catalyst has helped us to manage our NPS, proactively predict issues, proactively and resiliently resolve these issues, right? So this is one of the main thing, the main goal for this catalyst, to ensure that our NPS, customer experience, is improved. And then when you come to the CSP, of course, when you have a happy customer, what happens is simple. It's first and foremost, you have more money coming. It drives our revenue comes up, we reduce operational overheads, and then service availability goes up, and cost savings, because this is driven by AI. A lot of things are automated, a lot of things are predicted, and most importantly, with the underlying efficiency the AI brings to us as a CSP, it's all wins for you as a CSP. And on the industry part, of course, you had Andrea talk about the contribution this project has had for us. First and foremost, on the ODA part, we have been able to even suggest new ODAs for the TM forum to look at and to adopt. On the open APIs as well, the same thing. And then most importantly, the contribution to the autonomous network is unbelievable. So this is taking us to autonomous network level 4 and beyond. And then for the society at large, I mean, it's all green, and you can run your businesses. You have a stable platform to run your businesses. Then, I mean, the society at large, we are creating more. We're creating more opportunities for people to have to be able to use our network for much more innovative ways. And then as well, as we heard, we had partners that looked at the energy savings, Changwan Telecom, and NIIT, I think. So basically, it's all about energy savings. We are saving consume, and then we have the dynamic resource allocation when it comes to the RAN sites. I mean, it's all green for us in the society, and basically, these catalysts have taken us to another level that we can only dream of. But the good thing here is that it has been implemented. It works. That's the good thing here. It's working, and once again, I'm really glad we're on this note. I will hand over to David to conclude the session.
Yeah. And before we thank you, Maria. And before we completely conclude, I want to spend just literally 2 minutes on one short side note. Of course, with all the fun we had together and with being at the show and wanting to show people things in a innovative way, I don't want to miss out in at least mentioning that we also had our card game at the show, which was specifically designed to our Catalyst to have in a playful way also the possibility for people to actually interact with this. I'm turning off the music here. But just to show you a quick hint on this and keep maybe the rest for offline discussions, we also had a game where we were, for instance, showing it's about protecting the subsea cable and solving errors before they actually touch the cable. And then we were explaining people what it means to have predictive maintenance. So if you switch predictive maintenance on, you suddenly get your indicator before the problem actually happens, which gives you much more time to actually solve the issue. And what we all want to reach at the end of the day is autonomous network level 4 or 5, where everything is happening magically, automatically, which is actually the TM Forum AI mode. I'm switching it on now. And now I can put my hands off the keyboard and you actually just see that problems are being solved before they even really appear, and they never affect the customer. And with that short fun moment, I just want to hand back to my colleague David Tomajan to close the session. And thank you again for everyone for presenting together today. And most of all, for doing this together. You see more partners of the team here. It was really a great pleasure to work together. Thank you.
Okay, I think that concludes the video portion. So we will go ahead and close this portion up, and then we can open it for Q&A. But for now, I just want to thank everybody for your time, for coming in, and for allowing us to share this really, what we thought really exciting project. Working together obviously is always a really enjoyable opportunity, and it's these catalysts are really a unique chance to come together and bring different skill sets to look at problems from different perspectives, and everybody bringing in their individual skills and expertise to find a collective solution. So thanks again, and those of you who are here live will stay in and field questions, and I'm going to go ahead and stop the video now.